Today we're going to look at 2.1 part 2. Bless you. And we're going to look at two formulas in this section. Okay, one of the formulas is going to be used to find the length of something. The other one's going to be used to find the area. Both formulas are going to have a spot we need to plug in an angle. And it's important that we use our angles in radians. Okay, but I'll write that down. All right, so let's take a look at that diagram. So it's similar to a diagram I drew yesterday. We have a circle. Except inside the circle, instead of just putting one angle, I put two angles. Now, whenever we want to label an angle in trig, and we don't know what it is, we use a variable, just like in algebra. But most of the time in trig, you use a Greek letter, okay, to represent an angle. This is the Greek letter theta. Just a variable that represents an angle we don't know the size of. And that'll be consistent for this entire class. Anytime we don't know an angle, I'll always use a Greek letter, so then you know, okay, he's putting a Greek letter up, he must be talking about an angle. Different Greek letters we use, but today just theta. All right, and S represents the length of the arc created by that angle. Okay, so I've got theta, and then S is the arc that's created from that angle. And then I have theta 1, which in this case looks a little smaller. Not really important, but it does look smaller. And it creates an arc, and I called that one S1. So I have two angles and two arcs. Any question on that diagram? Okay, so what I want to look at is what happens to the size of this arc as you change the size of this angle. So let's look at an example. And here's a circle. And I'm going to draw an angle just like that. And the arc that it creates is like that. Now, how big of an angle did I just draw? Yeah, I drew a 90. Good. So you got a 90-degree angle. And how much of the circle does that arc take up? A quarter. So when we have a 90-degree angle, the arc is a quarter of the circle. All right. Let's try another one. Let's this time double the size of the angle. Draw another circle. And here is an angle that's 180 degrees. If I double the size of the angle, I get 180. How much of the circle does the arc take up now? Half. So what ended up happening is if you doubled the size of the angle, it also doubled the size of the arc. Those two things always change together. If I were to triple the size of an angle, it would triple the size of the arc. If I were to take and make this angle half as big, it would make, if I made the angle half as big, it would make the arc half as big. When two things change like that, that's called proportional. Not everything works like that. Okay, sometimes, for example, as one thing goes up, another thing goes down. Okay, but in this case, as one thing goes up, the other thing goes up with it. All right, so in this case, 100-degree angle, the arc is half of the circle. Okay, so again, that's called proportional. As one thing changes, the other thing changes exactly the same way. And when two things are proportional, like the size of the angle and the size of the arc, we can set up what is called a proportion to try to solve the problem. So a proportion is just two fractions equal to each other. So let's set up a proportion. In a proportion, you have four things you have to fill in. A numerator and a denominator on the left, numerator and denominator on the right. These are the four things we're going to fill in. And again, the only reason I can set up a proportion right now is because I showed you as one thing changes, the other thing changes exactly the same way. Arc size and angle size are directly connected to each other. If they weren't, we couldn't do this. All right, now when you set up a proportion, the only thing you have to do is make sure that you are consistent. Whatever you do on the left for your setup, you have to do the same thing on the right. So let's start with these two. Okay, I'm going to put the arc on the top, and I want to put the size of the angle on the bottom. Now I have to set it up the same way on this side. What's the other arc that I have labeled in this picture? Now, S1. So that would have to go in the top. And what's the other angle that I have labeled? Yep, Theta 1. Yeah, Theta 1. So there's a proportion that we can set up that represents what's happening here. Any question on that proportion? Right. And the way you could use it is like, let's say you know you have an arc that takes up half the circle. That's an angle of 180 degrees. So now if you had an arc that takes up a quarter of the circle, how many degrees would that be? That's basically what the proportion is we just set up. And we could solve that by cross multiplying. We already know the answer is 90, but if you cross multiply, you would get 90. Now, this proportion is really only useful if we can fill something in. Okay, you've got to have numbers in a proportion if you want to solve it. So let me show you something a little simpler with like inches and feet. I think we might have done one like this yesterday. Can somebody give me the conversion between inches and feet? What's the conversion? Jason?
12 inches per foot.
12 inches in 1 foot. So this side is just something you have to know. How do you figure that out? Well, you don't. It's just something you have to look up, that there's 12 inches in a foot. You can't calculate that. Right? It's a definition. Now, once I have a true fact on one side, I can put something I want to find on the other side. Like, let's say, 8 feet is how many inches? All I have to do is cross multiply, which basically is just 12 times 8, and that tells me how many inches in 8 feet. But this was the whole key. I had to have something true on this side. Now, what if I did this? 24 inches in 2 feet equals same problem. If I were to solve this one, would it give me the same answer as the one above it? What do you think, John?
Yeah.
Yeah. Give me the exact same answer because this is still a true fact. It doesn't matter what true fact you put on this side. Simpler is better, but you can put anything you want. So in 24 inches, there's 2 feet, 12 inches, there's 1 foot. The point is, it's a fact that's true. Now, let's go back to ours. We have to fill something in that's true. It doesn't matter what side you put it on, but you just need something that we know is true. If we let theta 1 be a certain size, then we will automatically know the arc length. And this is something we did yesterday. Does anybody remember if I let this be 1 radian? What would it automatically make this arc the same as? Anybody remember? If you have an angle that's 1 radian, this arc is automatically the same as something else. in the circle. Yep.
The same as the angle.
On a unit circle, it could be the same as the angle, but on any circle, it's always the same as, yep, the radius, yes. So if you make that angle 1 radian, then that arc is always going to be exactly the same size as the radius. That's our true fact that we're going to plug in on one side of this formula. That fact is just like saying in 1 foot there's 12 inches. Why is that true? Well, I don't know. That's just the way they defined it. Same thing here. If this angle is 1 radian, then the arc is automatically equal to the radius. So let's fill that in. Let's fill in that for theta 1, and we're going to fill in that for S1. All right, so the left-hand side is going to stay the same. S over theta equals R over 1. Right, and I think I've mentioned it a couple times, but how do you solve a proportion? Anybody remember the name of the thing you do? 2 words, ends with a C. Yeah?
You cross multiply.
You cross multiply. This times this equals that times that. And when we do that out, that's the formula to find the length of an arc. So S times 1 gives me S, and R times theta is just R times theta. So that's the arc length formula. Now that we have that formula, we don't have to go back through and figure it out every time based on a proportion. You could, but it's a lot easier to just stick with that formula and just use that. So, 3 variables in that formula. That is your arc length. That's pointing to the S. R is the radius of your circle. And what did we say theta stands for any Greek letter? It usually represents, Jade?
An unknown angle.
Yep, it represents an angle. And anything special that we assumed about our angle early on? Yep.
It's the same, wait.
So I'm thinking like in terms of the units. When we started out, is there anything that was...
You said that it's equal to 1 radian?
Yeah, we used the fact that 1 radian gives you an arc length of R. But the key is we started with radians. That means this whole formula is based off radians. Okay, so that's the arc length formula. You'll always be given 2 out of 3 of the variables. You plug them in, and then you solve for the third one. Remember, the S and the R are both measurements of how long something is. So when you write your final answer, you should put a label of length. Could be inches, could be centimeters, whatever label you need to put. Now, sometimes people get a little confused because they're like, well, wait a minute, you supposed right here that this angle was 1 and this angle was R. So does that mean you can only do it if there's a 1 in the problem? Well, let's go back to this. Right here, you suppose that there is 12 inches in 1 foot. Does that mean I can only convert things between inches and feet that have a 1 in them? What do you think, Tyler? No. Okay, I can't. Oh, I'm sorry, we got 2, Tyler and Tyler. Okay, I'll try to be clear about that. Yeah, just because you assume here that there's 12 inches in 1 foot, just because there's a 1 here, doesn't mean you have to convert something with a 1 over here. You can plug in anything you want and convert between inches and feet. It's exactly the same idea with this. We only picked a 1 because it's an easy fact about angle size and arc size. When we did inches and feet, we only picked a 1 because that's an easy number to convert between inches and feet. But it has no effect on what numbers you can actually use in the formula. It's just an easy fact to remember that was true. And that's the whole key. You set up a formula, you got to start with something that's already true and build off that. And that's what we did. So S equals R theta. All right, so one way you could get a question would be like this. You just write the whole thing out. So the directions here say find the length of the arc. And there's really only 2 things you need to know. You need to know the size of the angle, and you need to know the radius. So this problem could be written a lot more concise if you just drew a picture. And in the next one, I'll just give you a picture instead of writing it all out. But I want to make sure we can look at it as a description and figure out which letters we're given and which ones we have to find. All right, so we've got a circle. And it says we have an angle in the circle of pi over 3 radians. And we have a radius of 4 inches. Find the length of the arc. So, by the end of today, we're going to learn 2 formulas. One for arc length and one for area. The first thing you have to do is figure out which formula this problem is about. Well, if you read the last sentence, it says find the length of the arc. So this is definitely a problem about arc length. And Brian, can you remind me, what's my formula for arc length?
It's S equals R theta.
Yep, perfect. S equals R theta. So we're given 2 numbers. We just have to figure out where they go. So Dylan, what is this pi over 3? It says we have a central angle of pi over 3. Which letter is that?
The S.
What does S stand for again?
I don't remember.
So, yeah.
Arc length?
So S is arc length. What's this question asking us to find?
Find the length of the arc length?
Yeah, we're finding the arc length. So S is what we need to find. So they're not going to give us S. So it's one of the other 2 variables.
R?
Which one? This one?
Yeah.
So if you read this, it says an angle of pi over 3. So pi over 3 is what the angle is in this problem. We have an angle of pi over 3, and the angle is always theta. Okay, so my angle in this case is pi over 3, and you're going to fill that in for theta. Now, radius of 4 inches. What letter is that going to get plugged in for? Alec? Yep, that gets plugged in for R, and then we do it out, and that's our answer. So we have S equals 4 times, my angle is pi over 3. If you want to make the 4 a fraction, because the other number is a fraction, you can, just by putting it over 1. And now we just multiply straight across. Remember, when you multiply, you don't need a common denominator. So Haley, what's 4 times pi? How would we write that?
It'd be 4 pi.
Yep, it's 4 pi divided by, and Tyler, 1 times 3? 3. 3. And that is my answer, 4 pi over 3. Now, what did we just find? The length of the arc. In this problem, what was my length unit? Inches. That means we should put inches on that. The only thing they might ask you to do with it from here is type it in and get a decimal. And most of the time, you're gonna be able to leave it just like that. But if they wanted a decimal, just like yesterday, always use the pi button. And you get about 4.19 inches. Okay. Any questions on finding the length of the arc there? All right, let's try another one of those. This time, a little bit different the way I'm going to give you the problem. It's a diagram. And we've labeled an angle of 130 degrees and a radius of 8 feet. All right, so now, before we do anything, does anybody notice something in this problem that we got to be careful with? Yeah.
The angle is in degrees.
Yeah, the angle's in degrees. So the first thing you should do right away, off to the side, fix this angle so it's not in degrees. Okay, so let's figure out what that is. Alright, and how about Ethan? Can you remind me from yesterday, how do we change degrees to radians? Yep, I'm going to multiply by pi, divide by 180. I'm not worried about getting a decimal for this. I want to reduce if I can. Both the top and the bottom are divisible by 10. So the angle is 13 pi over 18. Any questions on how I got the angle? Okay, so let's put down our formula. How about Justice? Can you remind me again, what's the formula for arc length?
S equals star theta.
Okay, we just figured out theta, 13 pi over 18. Alright, so I got that. Kavani, what else did they give me in this problem?
The radius.
They gave me the radius, and how much is that?
8 feet.
8 feet. So multiply by 8. Again, if you want to make it a fraction, you can. And that's going to give me the arc length. Noah, before I multiply, is there anything here that I can do to simplify it a little bit? No. I think there's something we could reduce there. Do you see a number that divides into the top and the bottom?
2. You can divide them both by 2.
Yeah, we can divide the top and the bottom by 2, the 8 and the 18. So, at least if we do that, it makes the numbers a little smaller. And I think it actually makes them small enough, we can probably just finish it up without a calculator. 4 times 13 gives me how much? Yep. 52. So we have 4 times 13 pi, so 52 pi over 9. And unless they ask for a decimal, you don't need to do that out. You just leave it like that. Now look at the variable you just solved for, and then ask yourself if you should put a label on it. Yeah?
Should we use feet since that's the radius?
Yep, it should be in feet because you just found the length of something, and in this problem, lengths are in feet. Any question on that one? All right, so 2 examples where you're solving for the same thing. Second one had the extra step of changing the angle to radians first. Let's try this one. So this time we have an arc length of pi over 4 centimeters and a radius of 12 centimeters. find the angle. Okay, so now we're finding something different. Ariana, when we look at the pi over 4 centimeters, what letter does that get plugged in for?
S.
Yeah, it says you have an arc length of, and then they tell you a number. This is arc length. So there's my S. And John, how about the 12 centimeters?
That would be R.
That's my R. Plug that in right there, and then we're going to solve for the rate, the angle. All right, so we have pi over 4 equals 12 theta. And Gina, how would I get rid of this multiplying by 12 and move it to the other side? Yeah, we're going to divide both sides by 12. So when you divide by 12, it puts a 12 in the bottom on that side. And when you divide the other side by 12, it's the same as just putting times 12 in the bottom. Okay. That'll divide it by 12. Dividing something by 12 makes the denominator 12 times as big. And that's what I did right here. So that's gone. And for an angle, Natalie, what's going to be my final answer? Yeah, pi over 48. Okay. And Emma, that's an angle, so what is that? Pi over 48 what? It can't be centimeters, because centimeters would be measuring a length. What unit is our angle automatically in all the time? Noah?
Radian.
Radians. Theta is always automatically in radians. So when we wrote that, the angle is always in our radians. So do I need to write RAD on that? Pi over 48? Nope. You leave it just like that. Okay, so the only time you don't have to put a label on it is when you are solving for the angle, because we don't write RAD. Any questions on that one? All right, let's try one more before we do the last formula. So we've solved for an angle, we've solved for the arc length. Now we're going to solve for the radius. And Bridie, can you tell me, is there anything here that I might have to deal with first before I even plug into my formula?
Making the 36 degrees and changing it.
Yep, we have to change that. What do we have to change it to?
Rad.
Yep, we want to change that to radians. And if you do that out, you're going to get, that goes in evenly. So it's pi over 5. Okay, so there's our angle. Okay, pi divided by 5. How about Dylan? What else have they given me?
The 13 feet.
Yep, and that's going to go for which letter?
S.
S, good. So S equals, the directions are find R, so we don't know that, times, and my angle is pi over 5. So now we want to move this pi over 5 to the other side. You can move that exactly the same way you would solve something like this. Whenever you have a fraction in front of a variable, does anybody remember what you can multiply both sides by? And it will move the 2 and the 3 at the same time.
Inverse.
Not the inverse, but it's kind of like that, yeah?
The reciprocal.
The reciprocal. if you multiply by 3 over 2 and 3 over 2, it cancels both of those numbers at the same time. So what about on this one? What could I multiply both sides by to get r alone? Yeah.
5 over pi.
5 over pi. And 5 over pi. Pi in the top, pi in the bottom, 5 in the top, 5 in the bottom. Everything cancels out. And we're left with r equals 5 times 13. How much is that? Yep.
65.
65 divided by pi, and we found the radius. The radius is a measure of how long something is. So what should be my label on this one? Yep. 8. Any questions on that? So that's how you find the length of, or that's how you use the arc length formula. Okay? 3 different things you could find. Last formula we're going to look at is area. Okay, how do we find the area? So this is what we just found. Okay, what's in red. What we're going to look at next is how would you figure out that? Now, is that shape there, is that a triangle? What do you think? Tyler?
No, because the arc on the other side.
Yeah, it's more like a slice of pizza. That's really what the shape is. You have 2 sides that are straight, then you get that third side that's curved. So this shape is called a sector. Okay? That's what this shape is called. So we're going to look at how do we find the area of a sector. And I'm going to start out with a diagram just like I did last time. And the first thing we're going to look at is the connection between the size you make this angle and the size of the area that it makes. And I want to see if there's a connection between the two. This time, I'm labeling the angles like I did before, theta and theta 1, but I'm not labeling the arc. Okay, I'm not focusing on that. I'm labeling the area, which is that region in there. The bigger area I labeled A, and the smaller area I labeled A1. Okay, all we have to figure out here is the size of the angle and the size of the area connected somehow. Okay, let's take a look and see. Make a circle. What size angle is that?
90.
Yep, that's a 90. So if you have a 90-degree angle, how much of the circle does that area take up? Yep.
A quarter.
Takes up a quarter, just like the arc length. Takes up a quarter. So if you have a 90-degree angle, area is 1/4 of the circle. Now, let's see what happens if we double the angle. I'm hoping if we double the angle, we double the area. Well, let's see. Here's my angle. 180. I shaded in what it covers. How much of the circle is shaded in now if you double the angle? Yeah? Half. So if we doubled the angle, then the area also doubled. So what that means is the same thing that happened before. The size of the angle and the size of the area are directly connected. If you double the size, if you triple the size of your angle, you'll triple the size of the area. If you make your angle half as big, you'll make your area half as big. So it means angle size and area are directly proportional. And when two things are proportional, we can set up a proportion, and that will help us to figure out the formula to do this.
I was about to ask, what is the formula?
Yeah, so we're going to figure out what that is right now. So let's set up our proportion. We've got four things: an area, an angle, an area, and an angle. You can't really go wrong with what you started. Can somebody tell me what I could put on the left-hand side using the four things I circled? It's going to be very similar to arc length. Yeah? Theta over... Sure. So she put the angle in the top, she put the area in the bottom. Do it the same way on the other side to be consistent. What's going to go in the top? Theta 1. And in the bottom? A1. Now, a proportion with four variables in it is useless. The only way the proportion becomes useful is if you can fill in a true fact on one side. And there, right here is where we're going to try to fill in something that's true. Let's go back here. So, 90-degree angle, we have a quarter circle. 180, half circle. Well, let's keep going. Let's say I put my initial side here, and then I put my terminal side here. Now, the area wouldn't be quarter or half. I've made the angle so big that now it's the whole circle. What would be the size of this angle if the area takes up the whole circle? Yep.
360.
360 degrees. And anyone remember what that is in radians? 2 pi, yes. So if your angle is 2 pi, the area is the entire circle. This is a fact that's definitely true. Like saying in 1 foot there's 12 inches. If your angle is 2 pi, your area is the whole circle. That's true. The only thing we need to know is what's the area of an entire circle. Does anybody remember what the formula is for area of a circle? Yep, Tyler?
Is it pi r squared?
Perfect, pi r squared. So here is the true fact that we can plug into the proportion to make it useful. If you have an angle that's 2 pi, then you have an area that's automatically pi r squared. Those two things are connected. 2 pi gives you pi r squared. Any question why that fact is true? All right, so let's plug that into our formula. So on this side, we're going to leave it blank. On the other side, we're going to fill in a fact that we know is true. If you use an angle that's 2 pi, you would automatically have an area of pi r squared. Here's my 1 foot 12 inches. It's just a fact that's true. Any fact that's true would work. Doesn't matter what the fact is, it just has to be true. All right, anybody see anything that's going to cancel out here before we cross multiply? Yep, the pi. So now let's cross multiply. So you end up with 2a equals r squared times theta. So that's basically our formula, but we don't want a formula for double the area, we just want a formula for the area. So how would I get rid of this 2? Yeah, Katie?
Divide both sides by 2.
Yep, divide both sides by 2. Sometimes people say multiply both sides by a half. That's how our book does it. So if we multiply both sides by 1/2, you end up with these canceling. And you get area equals 1/2 r squared theta. You're not wrong if you say r squared theta over 2. It's the same thing. But I'm just doing it the way the book does. Okay, and that's the formula for area of a section. Using it is exactly the same way you use the arc length. You plug in 2 things and you find the third one. So that's the area. Okay, R is going to stand for what? Radius. And angle is going to stand for, well, never mind, I just told you. Theta is going to stand for angle, but the angle has to be measured in radians. Now, the nice thing about using radians is look at what happened right away. The pi's canceled. We could write the formula in degrees. And what would be right here would be the number 360 instead of 2 pi. But if you put the number 360 here, those pi's wouldn't cancel out because you wouldn't have a pi. So the formula is actually nicer when you write it in radians than if you did in degrees. All right. Questions on that formula? So now, when you read the problem, figure out, are they asking me to find area, or are they asking me to find arc length? And pick the formula you need. Example 5. I would say generally if the problem is written well, you can look at it pretty quick and figure out, is it an arc length problem or an area problem? What's this one asking me for? Arc length or area? Yeah, it's asking for area. Okay, good. So once I figure out what it's asking for, the first thing I usually do is just write that formula down. Okay, Tyler, can you tell me what's my formula for area?
Half r squared theta.
Yep, 1/2 r squared theta. Now, if I read the directions, it says find the area. So they're not going to give me that. Okay, how about Haley? What's the 4 in this case?
So radius.
That's my radius. And Caitlin, what's the pi over 6?
Mapping the theta.
Yep, that's your theta. And it's already in radians. I know that because there's no degree symbol on it. So I don't have to convert it. If it was in degrees, I would have to fix it. Pi over 6. And now we just multiply out the right-hand side and follow order of operations. So Allie, what's 4 squared? How much?
16.
Yep, 16. And then what if you take half of 16?
8.
So we have 8 pi over 6. And Jade, if I reduce here, what does that reduce to?
4 pi over 3.
Yep, that's going to reduce to 4 pi over 3. Notice I left a little bit of space when I circled my answer. Ryan, what did we just find?
You found your R, right?
Nope, we were given R. R was 4.
Oh, your area, sorry.
Yep, we found the area. So what should I put for a label?
Oh, centimeters squared.
Yes, there you go. Centimeters squared because it's area. question on that? All right. Let's do, there's only two left. So this one we're finding the radius, this one we're finding the angle. Let's do the one where we have to find the radius. We'll probably skip the angle one. All right, so find the radius. Now, how do you know if you should be using the arc length formula or the area formula in this problem? There's something up there that kind of gives it away. Yep.
It's an inches squared, so that's the area of the sector.
Yeah, this isn't an arc length, it's inches squared, so that's an area. So we're definitely using that. And the first thing I see right away, I see something in degrees. That's no good. We have to change to radians. Anyone tell me what 45 degrees would be if you change it to radians? Yeah.
Pi over 4.
Yep, it'll come out to pi over 4, because you're going to multiply by pi, you're going to divide by 180, and 45 goes into 180 exactly 4 times when you reduce. Okay, so that will be pi over 4. Alright, now we got everything we need. So let's fill in the area. The radius, we're going to leave that as r, because that's what we don't know. And the angle is pi over 4. All right, so there's really going to be 3 steps to get r by itself. We've got to get rid of the 1/2, the pi over 4, and then the exponent of 2. Let's start with the pi over 4. That's like something we did before. Anyone know what we could multiply both sides by to get rid of the pi over 4? Yep.
4 over pi.
4 over pi. Now, you could do everything in one step, but I'm going to do one step at a time. Lots of things are going to cancel when you do that. 4 in the top, 4 in the bottom. Pi in the top, pi in the bottom. And what else cancels? Yep.
Both pi's in the other one.
Yeah. So we canceled out quite a bit there. So now we have 8 times 4 is 30. Yeah, 32. Equals 1/2 r squared. And that's it on to the other side. Okay, what could I do now to get rid of that 1/2? Well, Justice, what could I do here?
Simplify. Multiply by 2.
Yeah, you, just like we did before, multiply both sides by the reciprocal, which is just 2 over 1. So times 2. Again, if you want to put 2 over 1, you can. 2 times 1/2 gives me 1. And 32 times 2 is 64, and that's actually going to be a very nice number for our next step. So that's kind of a hint. Now we have an exponent of 2. How do we get rid of that exponent of 2? Yeah.
Square root.
We take the square root. When you take the square root of a fraction, you do the top and you do the bottom separate. Okay, so that's the answer. The only thing we have to do from here is clean that answer up a little bit and simplify it as much as we can. What's the square root of 64? 8. So that comes out nice. Now, there's something that's not good about that. Does anybody know what is technically not correct with that? I mean, numerically, if you type it in, that is the right answer. But it's not how you should read it. Yeah? Right, you're not supposed to leave a square root in the denominator. And do you remember what you multiply the top and the bottom by to fix that?
3.
Close, not 3, but you're close. Yep.
It'd be the square root of 3 over 8.
So whenever we multiply by something, you have to multiply by the same thing in the top and the bottom. Because when your fraction is the same in the top and the bottom, you're really just multiplying by 1. So we have to keep the same thing in the top and the bottom. But we're going to do it like that. So we're not changing the answer. We're multiplying by the same thing in the top and the bottom. What we're doing is rewriting it a different way. Now multiply straight across. 8 square root of 3. And what's the square root of 3 times the square root of 3? Yeah? 3. The square root of 3 times the square root of 3 is basically this. It's the square root of 3 times itself. It's the square root of 3 squared. And what happens when you square something and it has a square root? Those are gone. Okay. So that would be the final answer, doing all the arithmetic to clean it up. I just need my label. Inches. Okay, so when you have to solve for r in an area problem, that's probably the worst one because of the square root part. Sometimes this ends up happening. Okay, any questions on that? All right, so the homework for tonight, there's going to be a couple word problems. One of the word problems is going to have a clock in it, like an analog clock. It's going to ask you a question like, how far does the tip of the minute hand move between 12 and 4? Well, as the tip of the minute hand moves, what shape does it make that we're studying? It makes an arc. So the tip of the minute hand moving is an arc length problem. They'd have to tell you the length of the minute hand, or maybe it's like, I don't know, 6 inches. What is that 6 inches? Yeah.
The radius.
That's the radius, right? Because if this went all the way around, it would be a circle. So the radius is the length of the minute hand. And the other thing you need is the angle. Well, on a clock, the angle is very easy to figure out because everything's equally spaced. Think about something simpler. 12 to 3. What's the angle between 12 and 3? 90. So what does that mean the angle is every hour that you're moving?
30.
30. 30, 60, 90. So if you wanted the angle between 12 and 4, it's 30, 60, 90, 120. So there's your angle. The only thing you have to do is change that angle to radians. Okay? But that's the idea of the problem about the clock. And then the other one is about a pendulum that swings back and forth. As a pendulum swings back and forth, it kind of makes this motion. Well, what shape is that? That's another arc. And let's say the pendulum was 2 feet long. That 2 feet is like your what?
Radius.
That's your radius. Because if the pendulum went all the way around, it would make a circle. Right? And the circle would be the radius of the pendulum. So they'll give you an example like a pendulum is swinging through an angle of maybe 30 degrees back and forth. So if the pendulum is swinging 30 degrees, you can find the length of the path of the pendulum using your arc length formula. But that's a couple hints on 2 of the problems in the homework tonight. So that, again, is the homework for tonight. What I usually do in the video right before the day of the test is I put the topics. So I'll add these right now. So, topics on the test. Distance formula. Midpoint formula. Converting between radians and degrees. Both ways, radians to degrees, degrees to radians. And the two things we did today. Arc length and area of a sector. Not a ton of formulas, but maybe a couple formulas you'd want to write down. You can make a reference sheet if you want. The test will be on Edge Elastic, so make sure if you haven't signed up for that, you get signed up. I'll post this video in a little bit on YouTube. Okay, not in Schoology, but it'll be on YouTube. And then if you need anything, you can just copy it down.